forward on this computer. All righty, so we're gonna start by going over our homework, which again, I'm thinking if you did it, you understood it, unless you have some questions. So let's just talk about, I lost my packet. All right, what did you get as the depth range? I actually want to talk about that word range. What do I mean by a range?
Like the lowest to the highest.
The lowest to the highest. So in this case, I want the top of the crust to the bottom of the crust. So remember, the crust is only this actually thin black line. So it does start off at a depth of 0 and it just goes out a little ways. I said maybe to 100. So 0 to 100 kilometers for the crust. What'd you guys get for the asthenosphere? Do you guys mind going around the room? Most of you did it. We'll try it. Kat, what'd you do for the asthenosphere, the top to the bottom for the range? Okay. I couldn't hear you. Okay, I don't think it's quite, I don't think it starts, there's a little closer to 0 than 3, but the 600 is perfect. So I'm gonna go with 100 to 600. So if you were off by, I would give you 200 or so. So it doesn't have to be right on what we say, but as long as you're close. What about the stiffer mantle, Zach?
So for the asthenosphere, I put that number is 750.
That works.
So I put 750 to 3000.
Does it actually go, grab your reference table? Does it go all the way over to 3000?
Probably not.
Probably not. So that's the case.
No, it's like 2,900.
So this one is one where they will be picky. So we're talking about this section right here. This dotted line does not go over to the 3000. So I do think you got to be careful enough there to say it's not touching the 3000 line. What'd you get for the outer core, Felicia? 5,100. Yep, that's what I had too. And Sarah, inner core? 5,100 to 6,300. That works. I said 6,300. So anything that that was close there, I do want to point out. So that was this number right here, because the center of the earth is there. Read it down. So Sarah estimated to be 6,250. I said 6,300. Did anybody say 6,500? Okay, good. And I did want, that's what I wanted to point out. This isn't a half a box here. This is a little bit shorter than a whole half of a box. Like a half is, well, a half is closer to like this big. I don't think that's big enough to be a half. So not 6,500. So how far is it down to the center of the earth? We just discussed that, about 6,300. If you said 6,250, perfect. 6,200, fine. Not 6,500 though. And what's the depth at the mantle outer core boundary? So mantle, outer core, the boundary between them. Yep, that's the 2,900. Not quite 3,000. You could have said like 2,950, but not 3,000. It's definitely over a little further. Now, I think did I forget to talk about thickness with you guys because we ran out of time?
I had no idea.
Okay, so for thickness, I really just want to know how thick is it from here to here for each of the layers. So from the top of the layer to the bottom of the layer, how many kilometers is that? Really, I'm just looking for how fat is the layer. How would we figure that out? Yeah, so you already know where each layer starts and where it stops. So we know it starts at 0 kilometers and then ends at 100 kilometers. Well, how thick is it? 100. All you had to do was subtract those numbers. So you just do the top to the bottom and subtract them. So that's kind of helpful that we have them all right here. So again, you might have had slightly different numbers, but as long as your numbers kind of match up, then you're good. So the asthenosphere for us, we wrote down that it started at 100, ended at 600. So if you subtract those two, that would be 500. if you said, like, Zach, I know said, would you say 100 and 800 for the asthenosphere?
750.
So 100 and 750, so his would have been 750 kilometers. This one, I'm gonna need a calculator for that. There's no shame in using calculators, guys. In fact, I like when you use calculators because our brains are not always prepared to do math in our head. That's 2,150. This one is 2,200 and 1,200. So that one required a little bit of thinking, but not too much. Now, density doesn't really require thinking because it is just listed right here. So it does start with the crust, the granitic continental crust. That's 2.7 for the continental crust and 3.0 for the oceanic crust. What about the asthenosphere? I had questions about this all day. So here's the asthenosphere. If we read over, there's nothing exactly listed right here, but what you should see is this line right here that's labeled MOHO, which we're going to take notes on today. And this line right here, it includes the asthenosphere. So all three pieces of the mantle, the rigid mantle, the asthenosphere, and the stiffer mantle all have that same density of 3.4 to 5.6. And same with the stiffer mantle, 3.4 to 5.6. And then the outer core was 9.9. 12.2. You want to go around the room? Sarah, what's the density of the inner core? You got it. Sorry, I thought you guys were annoyed with me about going around the room.
Sure, I think it's video. You want to go around the
Guys, what happens when depth increases, density does what? Increases. Thank you. All right, Sarah still wants to go around the room. So Felicia, we're going to start with you. What is the highest approximate pressure? So this time I asked for the highest, not a range, but the highest pressure for the crust. Would you? I know. Sarah wanted to do it again. No, we're going reverse this time. No. Why is this one so difficult?
Because it's barely over.
It's barely anything. So I kind of picked, I'm making you do it because I wanted to talk about that.
It's 0.1.
It's not even 0.1, not for the crust, not for right here. I don't even think that makes it off the 0.1 for the crust. I don't think it really does. It might be like 0.0001, but you could honestly have stuck with just 0 for the crust. Do you want to try again and do the asthenosphere?
Yeah,
Do it. Grab your reference table.
Try again, Felicia.
Fine.
I can answer everything.
No, I want you to do hard things. I want you to do hard things.
I do. It's not physical.
So here's the lowest for the asthenosphere. Here's the highest. What would you estimate that to be?
I don't know.
Do it.
0.2 foot.
Really? You think it's 0.25?
0.3.
Really? Because you know how to divide these in half. So what would that mark be?
0.5.
That'd be 0.5.
And then half of that is 0.25, which is basically that.
Basically my foot.
It's like
0.1.
0.1.
I don't even think it's 0.2. I think we're
Rich,
definitely,
rich.
this is like halfway between
You are
0 and 0.25.
This is the mini figure out.
Oh, of course, because heaven forbid we just cross something out.
It's 10. Yeah.
You, no, watch, I'll show you. So if you had put 0.25, you know what you gotta do? You just go, and you change it to 0.1.
How did you get?
How'd I get what?
What
I couldn't hear you, what?
Pencil. So then you
What did you
can
say, Sarah?
erase your.
They came and fixed it. Stiffer mantle. Felicia, do you want a chance to recover here?
I want.
No, thank you.
Do it anyway.
I'll say Felicia.
Sarah, do it anyway.
It's all
Or
good.
Felicia, do it anyway.
I do it anyway.
Sarah, or Felicia. Wow, I did it 3 times in a row there.
I just talked it out, so.
So look on your reference table. Would you like me to put mine up there?
What are we
That-
gonna do?
Felicia, you
Stiffer
have fun.
mantle. the pressure?
1.5.
Shut up, please.
All right, Zach, you're all about outer core.
3.
Oh, I forgot to go that way.
Yeah.
That's what you were trying to tell me.
That's what we were telling you.
That's what you meant. All right, Destiny, sorry, you're on this one. Destiny, what's the inner core pressure? I forgot you too, Keith.
Miss Rich,
You
I
answered,
put
didn't you?
3.0.
Yeah, I wasn't, I stopped at Kate, all right,
It
never
was
mind.
exactly
Hey
on
Keith,
three.
what's the approximate depth at which the pressure is 1 million atmospheres? I also had 2,300. Cassidy, oh, you said 2,500? Is that what you mean by 250? 2,000,
Miss
that
Rich,
works, yeah.
Miss Rich, you know what's crazy? You went Sarah, Felicia, me, and then you just stopped.
I know, I'm a mess, what can I say? Cassidy, do you have the depth at 2 million atmospheres? I also had 3,500. Kat, how about you? Do you have 7C, 3 million atmospheres? What's the depth? Good answer. I like that. Hey, instead of her just saying no, she's like, hey, give me a minute.
I'm not her.
Yeah.
She's
I
Yeah,
like
you should
it.
learn from
I'm
Kat.
Lisa.
Oh, yeah.
So we want a depth at 3 million atmospheres. So you find the pressure where it's 3 and go down and tell me what's the depth there.
D.
Is it a little bit further?
Yeah. So she thinks it's a little bit further over.
There.
So again, guys, stay with me. There's the 3 million. We hit the line there, read down. It does hit at that dotted line. I think it's hard to say, maybe right on. So it's at the 5, maybe 5,100. I'm gonna go with the right on the 5.
Yeah.
And all together, guys, what happens when depth increases, pressure increases big time. Again, so how hot can the following sections get? Very hot. Good answer. Now we don't even have to do anything else. How about the crust? How hot does the crust get? About what?
1,000.
Maybe 1,000. Hard to say exactly because that's pretty squished over there.
No.
To be honest, guys, I don't think they would ever ask you how hot the crust or the lithosphere got. It's too squished. If they did, it would be multiple choice and only one answer would be remotely correct and all the rest would be way too hot. How about the asthenosphere? How hot does the asthenosphere get? See, I don't want to put anybody on the spot for these ones, but
Sarah?
here's the asthenosphere.
2,500.
2,500.
I answered the next two, so I don't gotta answer anymore.
Okay, sounds good. Keith, since I left you out before, how about the stiffer mantle? But we only want the hottest, just 5,000. I said 4,900. That was a perfect example of making sure you answer the question they asked. So they asked for how hot, they didn't want a range. And if this was the Regents and they said, what's the hottest the stiffer mantle could be, and you gave me a range, even if it was the correct range, I'd have to mark it wrong. Make sure you answer the question they ask. Outer core, do you get that one, Destiny? 8D. Oh, okay, so you gave me how cold it could be. So if we just go to the outer core, how hot it could get, this is the hottest spot it could be. So maybe 6,200. And then the inner core is 6,600. All right, for the sake of time here, I'm gonna go ahead with the next ones. I think this first one is really hard to read. 1,000 degrees temp. temperature is about right here. It's not very far off the zero, so maybe 100 or 200 kilometers. And then for 2000, again, that one's still pretty hard to estimate. I went with 400 kilometers. 3000 is 900. 4000, I got 1800. Then 3000 and 4500. Did anybody have any, like your answers were way off from there? How about this? Where does the temperature rate of change in temperature of, where does the greatest rate of change in temperature occur? How'd you do that?
Definitely.
So how'd you do it is what I want to know. So Zach, you said stiffer mantle. Do you know where you got your information from?
The reference thing.
What about it?
How big,
So you're actually wrong. So Zach said the stiffer mantle, and he's right. The temperature does increase the most in the stiffer mantle, but that's also because the stiffer mantle is a really thick layer. So it had a lot of time to increase that temperature. Felicia is correct that we wanted to look where the line was the steepest. Remember, a steep line, just like a steep hill. Like if you're going sledding and you're walking up a hill, it's going to change. Where it's steep is where you're changing the most elevation in the fastest spot. Now, Felicia said the asthenosphere. I'm going to kind of question that a little bit. Is there another place that's pretty steep too? The crust. So I would have accepted the crust or the asthenosphere. What part of the earth is the actual temperature greater than the melting point? Cassidy, you got that one, number 11? I don't think it's the inner core. So if we look, we want the actual temperature. Sarah, where is the actual temperature hotter than the melting point? Outer core. So this one, the actual temperature is higher than the melting point. So that's the outer core. And then where does partial melting occur? It's labeled. Partial melting happens right here. What layer is that? That's the asthenosphere. Okay, do you guys need different seats? Okay, then pull it together, please. Last chance. All right. Guys, how do you feel about page 10 of your reference table? Good. Felicia's good. How about the rest of you? How's lab? Oh, some of you haven't started the lab. You can start the lab next time you're in lab if you haven't already. How did that go? Did you start it? How did it go?
It's easy.
It
was a little bit confusing.
A little bit confusing at first, but how did like the figuring out what the temperatures were and the densities that go okay? All right, we'll see. The coloring was a little annoying. Is that what you're?
I kind of enjoyed that.
I know, we talked.
My yellow turns.
So we're gonna move on to a different concept. And to start this concept off, we are going to start with my very favorite song. Zach, you're gonna want to take your AirPod out for this one so you can see, so you can hear, I mean, my very favorite song. Then prove it to me, dude. So guys, my favorite song ever. Oh, first there's a commercial. Oh, this is pretty good too, but this isn't it. Here's my favorite song.
fellow scientists who sang, Henry Baker, you are a crazy man. Henry Baker, you are a crazy little man. They reminded him he had no proof for how or why the continents would do this. And the King showed just how or why you merely have one interesting hypothesis. You are a crazy man. You are a crazy little man.
I can't hear it, can you turn it up?
1930, on an expedition to Greenland, they locked up in a blizzard. When they finally found him, it was much too late, and they buried him in an icy mausoleum. 30 years after he died, a new idea came to light. It changed the way geologists saw the world, and our continental drift back to Earth. Now everybody sing, yeah! Alfred Wegener, you are a brilliant man. Yeah! Alfred Wegener, you are a brilliant, brilliant man. Continental drift, Alfred Wegener's theory, continental drift. Alfred Wegener's theory, continental drift. Alfred Wegener's theory, continental drift.
Guys, there's merch.
Alfred Wegener's brilliant.
So, I'm not lying.
I like the other continents just better.
No, quite possibly my favorite song.
Are you for real?
No, yeah, 100%. Because first of all, it's a catchy tune. Yeah, I mean, it is my goal to get it stuck in your head by the end of today. Not only is it a catchy tune, but it tells Alfred Wegener's theory pretty good. So did you guys actually listen to the words?
No.
I was dancing.
Okay, so we have to listen to it again?
No.
Okay, so did anybody actually listen to the words? Okay, let's start from the beginning. Who was Alfred Wegener?
Man.
He was a man, a crazy little man.
Man.
But what did he do?
It's being killed.
He was a scientist, and what was the first thing he noticed? Okay, so he noticed that the continents fit together like a puzzle.
Continental.
And what happened? What did everybody else think of his idea?
He was a crazy man.
He was crazy. Why was he crazy? Because he didn't have any evidence. So yeah, he saw that these continents fit together, but the rest of the scientific community was like, you idiot. So what if they fit together? There's no way they could have moved. We can't move whole continent. That's stupid. They called him a crazy little man, and the poor guy went to Greenland and died with all his science buddies thinking he was a moron. But what happened later, 30 years later? Okay, there was a change. And what did they discover?
He's a brilliant man.
But why was he brilliant?
Because the continental drift.
But why
Plate
was
tectonic.
because plate tectonic was now that evidence they needed. It was proof they can move. We can move a giant continent across the world. And so now, instead of being a crazy little man, what was he?
Brilliant.
He's a brilliant, brilliant man. So it has been my dream, as evidenced by one of my TikToks, to make this song go viral. And I think this is the year. I think I am ready to put pen to paper or video to TikTok and make this song go viral. And I think you guys are the people to do
Wait,
it.
can I record that so that way I go more viral because they won't believe me?
Okay, ready? I gotta repeat my sentence for Sarah.
Hold on, I wanna get. Okay, ready?
All right, you ready? It has been my goal since I first saw this song and since I was first introduced to TikTok to make that song go viral. And I think you are the people who can make it happen. I am offering extra credit to any of you who make a TikTok to that song. Don't have TikTok? You have a phone. You have some way of producing music out of a speaker. Put song to phone and make yourself on TikTok. Everybody who does it gets extra credit. If you go viral, you get extra credit. Okay? Do it. Okay? I'm counting on you guys, all of you, to make this happen. I think between my 75 students, one of you can make this happen. So extra credit to anybody who makes a TikTok to Alfred Wagner's, what is that, Amoeba People? It's even better, Continental Drift by Amoeba People. The song's out there, I know. The end. What if?
What if, they want viral, but I get extra credit?
If they go viral and you're not in the video, nothing.
It's a class,
Anyone, no, I'm not doing it as a class.
why?
It's an individual thing, because I know some of you have no desire to do this. Some of you do. So we, did you just live stream me? All right, it's good, I'm cool. You asked. You asked, it's okay.
Can you say it again?
No, No, but it's on my recorded YouTube now. But anyway, so that's out there, but we actually have to do some work with Alfred Wagner today.
Oh, no.
So, yeah, we do.
I get saying that.
So if you turn in your packet to page 6,
So if Felicia goes viral, I can get extra credit.
only if you're in the video.
What if I like keep my hand in there for 1 second?
All right, so what we're gonna start with is some background. Guys, now is not the time.
Yeah, dude.
So we're gonna talk about the evidence. Now, Alfred Wagner in that video, he did talk about how the continents fit together. That was not the first time you guys had heard that statement though, right? That the continents fit together like a puzzle? That was the first time you've ever heard it? Okay. If I'm assuming you've learned that one other time, at least in middle school or elementary school. It's come up before. The way they fit together like a puzzle is the easiest to see piece of evidence. But again, we have 10th grade this up a little bit. There's a lot more pieces of evidence than just that they fit together like a puzzle. And that's what we're gonna do over, well, it looks like we're running out of time today, but we're gonna start this tomorrow too. So for the background here, it says since the 19th century, people have thought about the jigsaw fit of the continent. They said that South America and Africa appeared as though they fit together. Okay? So evidence supporting continental drift. The Earth's crust is constantly moving both vertically and horizontally at rates up to several inches a year. A widely held theory that explains these movements is called plate tectonics. It was developed in the mid-1960s by geophysicists. The term plate refers to large rigid blocks of Earth's surface which appear to move as a unit. These plates may include both oceans and continents. When the plates move, these continents and ocean floor move as well. Continental drift occurs when the continents change position in relation to each other. While plate tectonics is a relatively new idea, scientists have been gathering data to support continental drift for a very long time. In 1912, Alfred Wagner and Frank Taylor first proposed the theory that 200 million years ago, the Earth had only one giant continent, from which today's continents broke apart and drifted together to their current location. Let's just get a little bit of this. What is the name of the theory that explains the movement of the Earth's crust? From the reading that we just did, which theory explains this movement? We talked about two theories in the reading. That one is plate tectonics. Plate tectonics explains the movement.
What is that big talk do?
And then, 1 week from today. Yep. And then number 2 says describe continental drift in your own words. What is continental drift then? It's in the reading. The movement of continents. The end. Or the continents have moved, either way.
Already done that.
No. So I meant to start this today, but I don't think we're going to get to it. So what we're going to be doing is tomorrow, you will be Alfred Wagner. And you will need to collect evidence that supports your theory of continental drift. Then you are going to write a letter to your fellow scientists to make them believe you. So tomorrow you're going to collect evidence to support your theory. You're going to write a letter or a postcard to other scientists about your theory. Your postcard will need to include a description of continental drift and a description of the evidence you found. There's going to be 5 pieces of evidence that you're going to find tomorrow in your travels around the world. And we're going to put our notes here in this packet.
Miss Rich, you're having too much.
Tonight, you have no homework other than to start brainstorming the best TikTok you can. And you do have test corrections. I know a bunch of you thought about doing test corrections. They are due a week from today. Yes.
Mhm.